Hi everyone, in this video I'm going to give an example of finding the marginal rate of substitution, so that's our MRS, when our utility function is a Cobb Douglas form. Now in my example I have two goods, good A and good B. The utility function is equal to A to the power of 1/2 multiplied by our B again to the power of 1/2. I'm then just going to use my formula for our marginal rate of substitution, which is we're going to take the negative of the ratios of our marginal utilities, and I'm going to put the marginal utility of A divided by the marginal utility of B. I won't get too much into the interpretation of our marginal rate of substitution in this video, but I will say we do have to be careful about which marginal utility is on the numerator and which is on the denominator. In general, the marginal utility associated with the good that we put on the numerator of our fraction will be the good that's on the horizontal axes when we draw our curves. The marginal utility that is on the denominator, that's going to be associated with the good on the vertical axes. So if we drew up an indifference curve associated with this utility function, then it might look something like this. A is on the horizontal axis and B is on the vertical. Now, once we have our formula set up, we do need to find our marginal utilities, which we find just by taking the partial derivative of our utility function with respect to each of our variables. So I'll do A first. So we're going to take the partial derivative of our utility function with respect to A. And we start just by taking the exponent on our variable A out to the front. So that's 0.5. But we have to take away 1 from the exponent now. So 0.5 minus 1 is negative 0.5. Now we are just taking the partial derivative here. So we do have this variable b to the power of 0.5. We're just going to leave it as is because we're treating it as a constant because we're only taking the partial derivative. And that's really it though. That's our marginal utility of A. We can then find the marginal utility of B, which again we can find just by taking the partial derivative of our utility function but with respect to B. So I'm going to start just by taking that exponent on our variable B out the front again. So we get 0.5. We're going to leave A to the power of 0.5 as is because we're treating that as a constant. And that's multiplied by B, but we have to take 1 off the exponent. So 0.5 minus 1, so negative 0.5. And now that we've found those two partial derivatives, we can just substitute them into our formula for our marginal rate of substitution. So our MRS is equal to the negative of the marginal utility of A, which is this guy here, divided by the marginal utility of B, which is this guy. And then we're going to just do some cancelling and simplification. So the 0.5s on the numerator and denominator cancel out. Now with our exponents, if we have a base that's raised to some power but it's in the denominator, we can pull it up to the numerator if we add a negative sign to the exponent. I will say I have done a video on the rules of exponents if this is difficult for you or if you're getting lost. It is an old video, but it is important to know these rules. It just makes life so much easier. So I'll link to that video below in the description. Let's work through this fraction though. This whole thing actually reduces to, we've got the negative out the front. That's multiplied by A to the power of negative 0.5. And then I'm going to think about that A to the power of 0.5 that's on the denominator. I'm going to pull it up to the numerator. I just need to put a negative on the exponent. So I get A to the power of negative 0.5 up the top. Now we can think about our B's. We have B to the power of 0.5 and we have B to the power of negative 0.5 on the denominator. Again, I'm going to pull it up to the numerator. It will get another negative and two negatives make a positive. So I get B to the power of, well, 0.5 all in all. Now with our expression here, we do have some like bases which are multiplied together. So we can just add the exponents together on those in order to simplify. So for instance, I've got A to the power of negative 0.5 times A to the power of negative 0.5. That will be equal to A to the power of negative 0.5 plus negative 0.5, which is just A to the power of negative 1. We can think about the b's next. We have b to the power of 0.5 times b to the power of 0.5, which will be equal to b to the power of 0.5 plus 0.5, so b to the power of 1. So we're left with our marginal rate of substitution equal to the negative of a to the power of negative 1 times b to the power of 1. And this simplifies to the negative of b divided by a. I've just dropped those exponents to the power of 1. They're implied. And so that's our marginal rate of substitution associated with this Cobb Douglas type utility function. And that's really it. There is so much more to say here. I just did want to do a little short example video though, so hopefully I can do more videos in the future. I hope that this video helped though. If it did, please like and subscribe. Thank you so much for watching.